Hello and welcome to Technical Utkranti, and today we are going to see three-sum problem. This problem was asked to me in one of the interviews I had given, and it was asked after asking the two-sum problem which we have seen in the previous video. So we have done these many problems till now, and the three-sum problem and two-sum problem are pretty much related. So let's understand the problem. We have an array of numbers. We need to find triplets, unique triplets in this, which sum up to the target value. For example, if target value is 0 and this is the array, then 1, 2, minus 3, 1, minus 1, 0, and 0, 3, minus 3. These three triplets sum up to the target value of 0. Now, how are we going to solve? So, we have an array 1, 2, minus 1, 0, 3, minus 3. Now, the brute force approach in solving this particular problem is to have three loops. So, I starts from the starting of the array and goes till the very end. J starts from I plus 1 and goes till the end. And similarly, K starts from J plus 1 and goes till the end. And we simply have to see if the number at I plus number at J plus number at K is equal to target value, then just include that into the solution. This approach is going to cost us O of n cube in time, and it does not require any extra space. So we can say space complexity is going to be O of 1. Now interviewer is not going to be very happy on this brute force approach. So the second solution is the same as what we have seen in two-sum problem. Here we are going to apply the dictionary over here. So as you can see, we have an array over here, and we'll save the entire array elements as key in the dictionary. So this is the first element is called key, and this is called the value. The special thing of dictionary is that it helps in searching the key in O of 1 time complexity. Therefore, the use of dictionary is being made to improve the time complexity of the algorithm. What will happen is, let me write down the array once again. We'll have I as we had I over here. Then we have loop for j, same as what we had in the previous solution. And then we'll be going to calculate the value target minus I plus j. This value is searched in the dictionary, and if it exists in the dictionary, then we query its index, and if the index is greater than the j pointer, which means that we have found a number which is among these numbers, and hence we have gotten the solution. And I number at I, number at j, and t of I mean t minus I plus j, this is included in the solution. The approach is very much similar to this approach, and it is just that we have used dictionary to improve or to replace the third loop that we were using. Okay, so we have improved the time complexity from O of n cube to O of n square, but we have increased the space complexity in the second approach. There is one more approach, and interviewer will be more happy in that approach, and let us understand the third approach as well. So the original array is 1, 2, minus 1, 0, 3, minus 3. While solving the problems of arrays, a lot of times sorting the elements in the array gives us a starting point to the solution. And the third approach involves sorting. Once sorted, it looks like this. Okay. So sorting takes n log n time complexity. Okay. Now I I pointer is placed as it was in the previous question, and in the remainder of the array we have two pointers, left and right. Now what we do is we calculate target value minus I, which in this case is 3, and we want L plus R to be equal to this value. So L plus R should be equal to this value in order to have L plus R plus I equal to target. Correct? So we see what is the value of L plus R. It is 2, which is less than 3. Therefore, we want to increase the value of L plus R. In order to do that, we need to move L towards right. If we had to decrease the value of L plus R, then you can guess that if I move right pointer towards left in the sorted array, then the value of L plus R would decrease. So, because we have to increase the value, we'll move left pointer over here and we get L plus R equal to 3. Therefore, the current pointers of I, L and R make one solution -3, 0 and 3. But we can get multiple solutions for a value of I. So what we'll do is we can move any of these pointers left, or left can be moved right or right can be moved left. So let's assume I moved L over here. L comes over here and L plus R becomes 4. 4 is greater than 3 and we need to reduce it. In order to reduce, we need to move right pointer to the left. So we may bring R over here and we get L plus R equal to 3 again. Therefore, -3, 1, 2 becomes the second solution. Then we can move either the left pointer towards right or right pointer towards left. And as soon as R is equal to L, we are done for the given value of I. Similarly, I would go on for the rest of the elements, and the same exercise would go on for the remainder of the elements to find all the solutions. I hope this solution was clear to you. Now let's go and look at the code of all the three approaches that we have seen till now. So this is the brute force algorithm, and its solution you can see over here. As you can see, we have three for loops nested one after the other, and we are comparing the sum of the elements to target and appending if it satisfies. And you can see that we have got the solution over here after running the program. In the second approach, we have dictionary based approach where we are storing all the elements and their index in the dictionary. As you can see, in the nested format, we have only two loops, and then we are using the power of dictionary in order to find the third element, the remainder element. The solution of the two approaches would be same, as you can see. All right. Now let's look at the third approach. In the third approach, we are first of all sorting the array. Then I'm running a loop over the array, and I have a left pointer which is just ahead of the pointer I, and the right pointer which is pointing to the end of the array until left is less than right, which means this is the end condition from where onwards for we'll not find more left and right for the given I. Okay, so what we are doing, if target minus I is equal to left and right, then we are appending the answer. I, left and right, both the elements we are appending it to the answer. Now we are moving the left pointer ahead, and these three lines of code just ensure that all the same elements are surpassed. So if the left is at 2 currently, then its movement to the next element should, I mean, the next element can also be 2 in the sequence, in the array, right? But left should surpass all the same elements. So that's what these three lines ensure. If the left plus right is less than what is required, then left is moved ahead, and it is moved ahead until a element bigger than the current left element is encountered. And if the left plus right are bigger than what is required, then right is moved until an element lesser than the current right is made, right? And similarly, this we are noting down the value of I, and over here we'll get new I, and we'll just see that if the older I and the new I are the same, then we need to skip that and move on to the new value of I. Okay, so I hope the code flow was also clear to you. And yeah, that's it. Maybe I'll just run the code and we'll have a look. As you can see here also, we are getting the same solution.